Alright, this is the second video of Logic. If you ever watched the first one, go watch it. The first one I covered sections 1 to 2, right? That's already 50% of the logic. This is section 3, and section 3, it might look little. It's only like one page, then you go into section 4. But this is extremely important, these steps, right? Because these steps is very important for the last section. So it's for the own video, right? So this section. So section 3, right? So now when we're doing a program, we need to create a code, right? We need to create a code. Now the only reason we create a code, right, is to solve a problem. We need to solve some problem in a business. So we need to do this code, right? But obviously it's not that simple. If you just think you need to be a programmer just to make a code and create a website or create something, that's not how it goes, right? You need to plan. So you need to plan using, well, they create these things called flowcharts. And this, I don't know what's this, to be honest, the way you pronounce it. I'm assuming the S is silent, so pew.code or PC code. I don't know. So when I refer to this, I'll refer to this as Pio.code. Pio.code, right? That's probably wrong. That sounds so wrong. Anyways, you get what's that, right? Pio.code. Okay, so in order to develop this program, right, it needs to meet the requirements specifically, right? A process usually performed to allow you to create a program easily, right? Now, the phase one, oh, the police is coming, you see? I think I mentioned the wrong Pisiko Kodo or something, I don't know. Anyway, phase one, right, define the problem. You need to define exactly what the problem is. You do this by simple defining the input, the process, and the output, right? Input, process, output. So in the input, you must think about what are you going to enter in this program. You need to think about what must you enter in the program. Process, you must think about what the program must do, the actual program. Is the actual program going to be any calculations involved, any comparisons, anything to like convert an input to an output? And then the output is obviously what the program must show, right? Must be able to provide or do. After you're done with the first phase, you go into the second phase, outline the solution. Now, although this might seem weird, like why are we outlining the solution in the second phase? It makes complete sense. Because in the third and fourth, you're going to basically build on this. So, outline the solution. In this phase, you need to determine what is needed in order to provide an answer to the problem, right? What is needed? The solution. So, this usually devolves, right? It involves determining the major process steps involved, so the subtasks. So what you need to do to get this problem done, right? You need to design or outline the solution, what type of interface you want, right? So what the system will look like, how it will interact with the users, the major control structures, the logic, basically all the design of what you want, the final product, what you want in the code. The phase 3, you develop an outline from phase 2 into an algorithm. Whenever they mention algorithm, they're mentioning these two things, flowchart or pseudo-code or whatever, right? So that's how they do it, right? So everything you said here, what you like, what you want the system to do, all the different components, you need to make it into a flowchart or an pisu code. After you do the flowchart or pisu code, you test the algorithm or flowchart, or you test the pisu code or the flowchart. So now you make this algorithm, you test this algorithm, then you code the algorithm. So the way I see these three are actually grouped, right? This is design the algorithm, test the this is the make the algorithm, test the algorithm, then you code the algorithm. So obviously now to test the algorithm in phase 4, right? You need to actually do the algorithm. So in logic will actually like do it, they'll give you diagrams and then it'll actually like be like x equals to 1 and then you'll give numbers and do it actually. So basically you need to test this algorithm if it works, right? Now code 5, right? Code the algorithm is the most important. You need to code, literally code, right? How basically this algorithm you created is like a mind map. So you use it now to code in the system, right? Code, right? Then the last one, after you do the code, you have to document and maintain the program. So this is the easiest. You document it, so like what you did in the program, when it was created, and so on, right? And then you need to like document how you created this program for other programmers. And maintain the program means if there's anything that needs to update the program for it to be working efficiently every year, you need to do it. And that is the whole of section 3. So remember, the first phrase, define the problem, the input, process, output. Second phrase, you outline the solution, what you want in your, basically what you need to do to solve the problem, so what you actually want. Then develop an algorithm, test the algorithm, code the algorithm, document and maintain the program.